Welcome to part 1 of Competency 9. In this competency, the teacher understands the geometric relationships and axiom structure of Euclidean geometry. In this video, we will work with the properties of lines and angles. In this video, we will not go into in-depth explanations of Euclidean geometry. The assumption is that you have already studied this particular geometry. Okay, but I will mention some key items, such as same side interior angle. And in this case, we are discussing two pair lines with a transversal. And then inside, for example, we have here supplementary angles, and that would be 65.15 plus 114.85. Add those together, and that will be 180. That's the interior part. That's because that's the inside of two parallel lines with a transversal cutting both of them. Okay, then we have the vertical angle theorem. Well, that just means that the angle across from another angle is congruent. And that is because of the fact that a straight line is 180 degrees. Of course, notice we only have one intersection there. We're not talking about other intersections. Now, the alternate interior angle theorem, that is kind of taking that idea, but extending it to two parallel lines with a transversal. Now, if I've said any terms that are unfamiliar to you, please go to YouTube to get help. At the end of all my videos, I have a reference section, and you will find a really fabulous name there for you to go to that particular channel, okay? And you will find by topic so many things, and you can refresh. I would say, in all honesty, I think every topic that you would need for middle school is going to be on that particular channel. They do a good job. Please trust some other sources for those very basic things that I will not be going over, okay? Because we do focus on calculator use for these videos, okay? All right, so let's move on to the next item. Now, with parallel lines and transversals and angles, we also can include the idea of a triangle. Okay, now that'll be the only polygon that we will include, because you can have transversals that cross but yet have parallel lines. Okay, well, let's look at these properties. All right, the longest side of a triangle is opposite the longest angle or greatest angle. Okay, that's a property that we should use all the time. The sum of any two sides of a triangle must be greater than the length of the third side. Definitely a property that we would use quite a bit. Okay. A segment attached to the midpoints of two sides of a triangle is parallel to and 1/2 the length of the third side of the triangle. Okay, that's the second picture here. All right. Now, the top picture shows you median. They want you to remember that when a median slices through a side of the triangle, you get two congruent, it's sliced into two congruent pieces, and that height can also be altitude, and we recognize that by the right angle and the dash line. Okay, now go back down to what we were discussing here. Okay, K to L, they're saying that that is slicing through. Okay, so if we look at this third property, okay, this means that KL and HJ would have to be parallel, and that KL is half of the distance-wise or lengthwise. It is half of HJ. Okay, so that would also mean that IL would be congruent to LJ. Now, there's a lot going on. I have time to mention it in my videos, but that would not be uh, what we would focus on in this video. Okay, now this last one, the sum of the three angles of any triangle is 180. Definitely useful. We have to use that. Okay, all right, let's go on to our first problem. Use the figure below to answer the question that follows. Okay, so we have an intersection with angles 2, 3, and 4. Number 1 says, if the measure of angle 1 is 5 times the measure of angle 2, what is the measure of angle 3? Okay, first off, since they're using the measure of angle 2 as a reference angle, I would call that x. Okay? Now we can look at the measure of 1. It is 5 times the measure of 2, which is x. So we have x and 5x, okay? Now we know that a line is 180 and two angles along the same line, add them together, and their degree measure is 180. So our setup is going to be 5x plus the x equals 180. Now, we can simplify and condense this, and then I will show you how we can use the calculator to quickly get this without doing a lot of calculations. Also, remember, we're looking for the measure of m. The measure of 3. Well, here's 3. Okay, this is the angle right here. Okay, I could draw that in better than what I did, but there you go. Okay, now we know it is congruent to 5x. So if we can figure out what 5 times x is, then we're good to go. Well, we can find out what x is right now. Okay, well, let's do some obvious condensings because 5x plus 1x is 6x. Okay, and we know that 180 divided by 6, we know what? We know that, okay, 180. I'm not going to do this all by hand because I want accuracy and I want to be quick, okay? So I know that's 30. In all honesty, I probably wouldn't even write down as much as I have here. This is just to help you get started. As we move along, you'll see that I use the calculator a bit more. Now, if I take 30 times the 5, because remember, that's equal to x, we need 5x. So times 5, what do we have? 150, and this will give us B, angle B. Now, if we are correct, and we say 3 is 150, when we add it back to x, we should get 180. So what was the value of x we got? It was 30. So plus 30, and of course, you see it's 180. Okay, always double check to make sure. All right, so now let's go to number 2, and it's telling us again to use the figure that we have here. Now let's see what it's got. It has to tell us what it's got to tell us. It says, given that AF bisects the measure of EAG, so here's EAG, okay? And this middle here, this is bisects it. And if you don't know what an angle bisector is, an angle bisector just simply cuts it in half. Okay, so we know the measure of this angle here, this entire angle, EAG, will be cut in half. So then this will give us a congruency here and a congruency here. Okay, so that whole angle, they're telling us that it is 38 degrees. Okay. All right. So that whole thing is 38 degrees, okay? Then it says that the measure of FAG is equal to 2x minus 1. So let's go back here. So it's saying that this angle right here is 2x minus 1. So let's put this all in a nutshell. We have an angle bisector, right? So this would tell me we have 2x minus 1, and that will equal 38 bisected, meaning sliced into two parts. Okay. Now, there's a lot of ways to deal with this, but this is what I'm going to do. Okay. What does 38 divided by 2 equal? Okay. That is going to be 19. Okay. Now, I know I'm going to be a little bit of a slick person here doing this. We just want the value of x, right? So watch this. I want you to go to table, clear everything out that's in there. 2x minus 1, the left-hand side. I want you to put in the left-hand side. Okay, now, what are we comparing? Well, we know that we're looking for a y value of 19. Okay, so let's push enter. Okay, and I'm going to use ask. In all honesty, watch. This is what we're going to do. Okay, I've already put in this side. So, and I have these options right here. And I want to know which one of these is a valid answer of X. Okay, so I'm going to push enter. Okay, now I can delete out each of these. See how I'm deleting? And there's only 3 lines there. As you saw me go up, there were only 3 lines. Okay, so what do I want to do? Let's try 40 and see if it equals 19. Nope. Let's try 30. It's not going to work. Let's try 20. No. Now, notice we've used all 3 lines. Put in 10, enter, and it types over. And that last one is what we want. And that is option D. Okay. Now, you might want to rewind the video and see what I did. Notice there are no calculations here. I allowed the calculator to do everything for me. Okay. And if you didn't know what a bisector was and the notations, please go look that up and refamiliarize yourself with these notations. They are used at the middle school level. I have to explain them when I teach and sometimes leave them up on my wall so the kids see them often and we don't have to explain it every time they see it. Okay, all right, let's go to number 3. Number 3, given that A is parallel to B and the measure of 1 is equal to 155, what is the measure of angle 2? Okay, this means we have 155 here. Now we have 2 parallel lines with a transversal, which is the black line. Okay, now we know that a straight line implies 180 degrees, so we can say 180 minus 55. That will give us an adjacent angle measure of 25. And because of the parallel and the transversal, I know that the adjacent angle, adjacent to 1, the angle adjacent to 1, is congruent to the measure of angle 2, which is 25. So that logically gives me option C. Okay, now let's go here to the next one. All right. So given that A is parallel to B, what is the measure of angle 3? Okay. Now we need to use the vertical line theorem. So that tells me that 2x plus 20 is congruent to angle 3. And then from the prior rule we used above in number 3, I know that the angle of 3 here is congruent to 5x minus 10. And by transitivity, meaning it kind of like flows, the equalities or congruencies flow from one to the next, I know that 2x plus the 20 is equal to 5x minus 10. Okay, now I could quickly manipulate those. I mean, yeah, quick, it'll take time. But let me throw a thought at you. What if we did this? What if I said, now these are two angles that we set equal. We know that, here, let me use my highlighter. I know that this angle is congruent to this angle, and that's what I had written. But if I subtract those two angles from each other, okay, I know that would equal 0. Okay, so let's put that in the calculator. So let's clear this out. We're going to go back to the table. I have it entered into the calculator. Please note that I'm using parentheses just as I wrote it, and that is to ensure my order of operations. Okay, I want to take the entire expression for that angle and subtract it from the first angle. Okay, now I am going to press enter. Now I can't use ask here because I'm looking for the value of x and that's not my final answer. Okay, but I can use auto. Now it might take me a second, but let's see what happens. It's just a thought. I can also manipulate. So I am looking for 0 for the y value. And notice how the y values go down. And that did not take long. So I know that x equals 10. Okay? And then I can take one of the angle expressions. It doesn't matter which one. I know 2x would be 2 times 10. I'm going to say plus 20. Well, I know that that equals 40. Let's see. That's 20 plus 20, and that is 40. Okay? But that just verifies it with this angle. Let's try the other one. So 5 times 10 is 50. Okay, minus 10, that also, sorry about that, also equals 40 degrees. So verify. Angle 3 equals 40 degrees because of the laws of congruency. Okay, all right, let's go to number 5. Okay, number 5. Let J be parallel to K. Okay. Label all angles of the image. Okay, so let's get started. Let's think about our laws. Okay, so if we have this one is 50, that means we go across, and that would be 50. Okay, and then the adjacent angles, okay, that means I would need 180 minus 50, and I know you can already see that that's 130. So this would be 130, and this would be 130. Okay, you can read what I'm writing there. That's 130, 130, 50, 50. Okay, that intersection is done. But now let's think about this. This black line that is cutting through. Be careful with this. Do one transversal at a time. See, this is the transversal that I'm working with, okay? So we can use our theorems, okay? So I know that because J and K are parallel, that if we have 130 here, then we have 130 here, and again 130 there. And then I know that we have 50 here, and I know that we have 50 here. Now, be very careful with this because you cannot translate these degree measures over to the other transversal. That is not valid, okay? So the other transversal going, let's say, with a negative slope, this other one, we'll have to wait to do it. We're not quite ready. We need to deal with this intersection that has 85 degrees. That would make more sense, right? Okay, so we have 85 there, that means we have 85 here. Now let's go to our calculator. 180 minus 85, that's going to give us 95. So that says you can have 95 here and 95 here. Now that is not an intersection that it's a transversal, but not here. This is the intersection of the two transversals. So we can't do anything else with those except for one thing. That happens to create a triangle. Well, we can do something with that. That is a weird looking 5. That is a 50. So we will take the two angles we have, subtract them from 180, and we will get the third angle of this triangle, okay? So actually, I'm going to say 180 minus the 50 minus the 85, and that equals 45, okay? All right. So now if that's 45, then I know that this is 45. Now wait a second. Adjacent to the 45s, or 45-degree angles, I have 2x minus 3. Okay, well, that's not going to be tough because we know if we add the two adjacent angles there, we will get 180. So this is what we have. We have 2x minus 3 plus the 45 equals the 180. Okay. Now you could quickly calculate that or put it in the calculator and look for 180. It's all up to you. So I'm going to enter it in the table. I'm going to clear everything out. 2x minus 3 plus 45. Okay, I'm just going to enter that and then see when my y will equal 180. Let's see what happens. Just out of curiosity, let's see here. We may have to manipulate, okay? Well, let's see. Looks like we're going to go up, and it's going up pretty quick. That's a lot of arrowing down. Let's see here. Yeah. Oh, there it is. 69. Okay. So that is 60. Oh, no, that's the value of x. Uh-oh. Ah, almost made a big mistake. So that's easy to do. Okay, that will not be our value. Okay, so how do we get our value there? Okay, well, that's when x equals, so we just need to substitute that in. So second mode, and I'm going to say 2 in parentheses 6, 9, close parentheses minus, oops, 3, press enter. Okay, that is 135. Now, did we really have to go through all that? Well, you're going to see that the number 6 will ask us about the value of x. However, we could have simply said 180 minus the 45 equals 135. Yes, we could have. Either way, we would still have to solve for the value of x. So we filled everything in that we need. Now, we are along a transversal again, okay? A different transversal, but we can use it with the two parallel lines, J and K. So this tells us that we have 45 here and 45 here, 135 here, and 135 here. And I do believe we have now labeled every single angle and obtained the value of x, okay? And look, here we go. Number 6 says, given that J is parallel to K, what is the value of x? Well, we've already found that value. X equals 69 degrees. Okay. All right, this is the last question in this particular video. Again, I want to thank you guys for watching and commenting and telling me when you have your successes. Kudos to those people who have passed their test. You guys, you're amazing. I knew you could do it. And also, Shout out to those people who have subscribed. You're helping us keep our channel free. Happy testing, everyone.